And here we go. Ladies and gentlemen, today we're going to show you how to do the calculations for assignment J, which involves refractive indices. And with these are two types of problems. One is this equation where the refractive index, this Greek letter looks like an N, it's not new, it's actually related to the English letter H. It's called a refractive index, and this is one of the few things in chemistry and physics that's the same. So this is a refractive index. The c is the speed of light in a vacuum, and v is the speed of light in the material. So now we're looking at actually differences in the speed of light in different materials. It slows down when the material is more dense, and that's what we're going to working with now. Any problems dealing with refractive indices and speed of light, you should be able to do. I am not going to go over an example on this. However, what we are going to go over is what we call Snell's law, which is this equation, refractive indice of 1, basically where the light starts, or is in, and the angle of incidence, which we call theta 1, is equal to refractive index of substance where the light goes in, and then the angle of refraction. So if I draw this, and let me get my pen going, pen color, let's go blue. Whoops, there we go. Come on, there we go. So if I come over here and I draw, this is my substance 1, substance 2, is the normal. Light comes in at this angle, this is theta 1. It comes out at this angle, this is theta 2. And this is n is equal to whatever number, this is n1, and this is going to be n2. So this is basically what we're looking at. And we know from the simulation that I showed you that light will slow down. So let's take a look at an example problem. And always note that we're getting more sophisticated with our problems, and you guys got to do some reading and interpretation of the reading. And so we've got a smallest diamond has a mass of 15 micrograms and a height of 0.11 millimeters. All right, we may need that, may not. Let's keep on going. Suppose a ray of light enters the diamond upon air. All right, so we're looking at light. Upon contact with one of the gems, it refracts at an angle of 22.2. So now this should click your brain going, okay, I need Snell's law. I'm dealing with angles and incidence of an index of refraction. So this that I'm underlining in blue is background. I don't need it. It's something nice to know. This sets up the problem that we're looking at. So theta 2 is 22.2 because it refracts. And here's my angle of incidence. This is theta 1. Now, so I'm missing N1 and N2. Refraction of 2, of material 2, and an index of refraction of 1. Well, we're looking for the diamond, so that's going to be 2, so we don't know that. And here's the key. The diamond enters the diamond from the air. For all this, N of air is equal to 1. Same thing as a vacuum. So the refractive index of air is 1. So let me go ahead and go to the next slide so I could do so we can work these problems. Okay, theta 1 is 65 degrees. Theta 2 is going to be 22.2. N1 is going to equal 1. And N2 is going to be, we don't know. So N1 sine of theta 1 is equal to N2 sine of theta 2. We want theta N2, so I'm going to keep this on the right-hand side. Divide both sides by sine of theta 2. And that's what we're going to look at. So N1 is 1. Now I'm going to put 1 here because there are going to be some problems where this it won't be in air, be in a different material, so we're going to have to put that in there. But we know that it should be, so sine of theta 1 is going to be 65 divided by the sine of 22.2. All right, for you guys, some of the problems on the test, you guys in calculus are not in degrees, they're in radians. Switch it. You need to have them in degrees. So 1 times sine of 65, and we'll divide that by the sine of 22.2, and then we'll have an N2, a refractive index of 2.398. I'm going to say that round to the 3rd decimal place, so we 2.40 as my refractive index of diamond. And that's my answer. Ladies and gentlemen, have a good day, and we'll see you at the next video.